Good morning, grade 1S students. I hope you are doing well. Today we are going to finish this chapter, light waves. Let's do a quick revision. What are light waves? Light waves are electromagnetic transverse waves. Look, it is a transverse wave. The particles are moving perpendicular to the direction of the wave that propagate in vacuum. This is a characteristic of electromagnetic waves. They can propagate in vacuum and in some material media. For example, light waves propagate in space, air, and water. In vacuum, the speed of propagation of electromagnetic waves is always constant, and its value is 3 times 10 to the power of 8 meters per second. We always represent the speed of light in vacuum as c. So always say that the speed of light in vacuum is c equals 3 times 10 to the power of 8 meters per second. And in theory, nothing can travel faster than light in vacuum. Electromagnetic waves can be also called electromagnetic radiations. Let's see the electromagnetic spectrum. The radiations in the electromagnetic spectrum are arranged according to their wavelength or according to their frequency. However, there are two types of light in the electromagnetic spectrum: visible light waves and invisible light waves. Visible light waves are a type of electromagnetic radiations that human eyes can see, and the frequency of visible light waves is between 4 times 10 to the power of 14 Hz, which gives the sensation of the red color, and 7.5 times 10 to the power of 14 Hz, which gives the sensation of the violet color. Everything in between can be seen by the naked eye. However, invisible radiations are a type of electromagnetic radiations that human eyes cannot see. Radiations whose frequency is less than that of red are called infrared, so these are infrared. However, radiations whose frequency is greater than that of violet are called ultraviolet. What is the difference between monochromatic and polychromatic light? From its name, mono means one, poly means many. Monochromatic light contains one radiation, one color, which means single wavelength, one frequency, while polychromatic light contains many radiations, which is the same as many wavelengths, many frequencies. Let's take, for example, the sunlight. The sunlight contains many radiations, for example, visible light, ultraviolet, and infrared rays. So, the radiations emitted by the sun are said to be polychromatic. However, if you take another example, the laser sources can emit light having one radiation. Thus, the laser beam is said to be monochromatic. Propagation of light. The material medium in which light waves can propagate is called the transparent medium. Monochromatic light propagates in different transparent media with different speeds. For example, the speed of yellow radiation, or the yellow color, is 2.99 times 10 to the power of 8 meters per second in air. However, it is different in another media. It is different in water. It becomes 2.25 times 10 to the power of 8 meters per second. Here, water is considered the transparent medium. This part is a revision of the previous videos. the phenomena associated with light waves. There are two phenomena, reflection and refraction. You can review the previous videos. In case of reflection, the wave, wait a minute. In case of reflection, the wave reaches the end. Let's suppose this is the end, and then turns back and propagate in the opposite direction. The speed, frequency, and wavelength remain the same. However, in case of refraction, the wave passes from a medium to another. For example, from air to water. In this case, the speed and the wavelength change while the frequency remains the same. I will focus here during refraction. So what happens during refraction? During refraction, the speed of light changes when it travels from one medium to another. The moment that a light ray leaves a certain medium and enters a new one, it refracts, which means that it bends away from its original path, so there's a change in its direction. You can actually observe this phenomenon in action in many ways in your everyday life. For example, try putting a pencil in a jar full of water, as shown in the image below. If you look at the pencil from above, it would look as through the pencil has bent in the water. It changes its direction. It looks like this. This is refraction. Here we can talk about the index of refraction, represented by N. So N is index of refraction. It measures the bending of a ray of light when passing from one medium into another. It tells us how much does this ray bend when passing from one medium into another. Mathematically, it can be represented as the ratio between two different velocities. The velocity of light in vacuum and the velocity of light in a given medium. So N equals C divided by V. The SI unit of both C and V is meters per second, so N doesn't have any unit. Let's see some index of refraction in several materials. In vacuum, the index of refraction is 1. In air, 1.00277. In water, in ice, in glass, about 1.5, and in diamond, 2.417. Let's take, for example, these two, N1, which is the index of refraction of light in diamond, and N2, which is the index of refraction of light in water. And let's compare them. N1 is much greater than N2. This means that diamond is more refractive than water. Today's session is finished. Please, I want you to do a homework. So please open your books, page 158, and do number 28, 31, 32, 34, part A. Thank you, and see you in the next video.